I've got all the parts cleaned for the HMT movement. Now we can go ahead and start reassembling it. The first thing we need to install is the center wheel. And here's our center wheel. You notice it has a long hollow tube on one side and the other side has a pinion and a shorter pivot. The long tube goes down and it goes through this hole right here in the center of the movement. The center wheel is installed. Now we need to put on the center wheel bridge, which goes over the top of it. On the movement right here, there's a hole for a screw, and then there's two pegs that stick up that are alignment pegs for the center wheel bridge. And the center wheel bridge has two holes for those pegs and one for the screw. I've got the bridge installed. You can see the two alignment pins that go up through the holes in the bridge, and then there's the hole for the screw that we're going to put in. And you can see that the top pivot of the center wheel goes into the jewel there on the middle of the center wheel bridge. Next, we need to install the mainspring barrel and the barrel bridge. And before we install the barrel, I'm going to put a little tiny drop of Mobius HP 1300 oil in the little hole here that the barrel arbor goes through on the base plate. I'm going to put it just on the inside edge of it there to give a little bit of lubrication for when the barrel turns. I've placed the mainspring barrel in the movement base plate. Now the side that goes up, if you look at the barrel arbor, one side of the barrel arbor has a hole in it with screw threads. That's the side that goes up. The plain side that doesn't have the hole in it goes down. Now the next thing we need to do is put the barrel bridge over that. Here's the barrel bridge. Now it has a hole for the barrel arbor to stick through right there. I'm going to put a little drop of the HP 1300 oil inside that as well to lubricate the top part of the barrel arbor before we put it onto the movement. I've got the barrel bridge installed and it's held on by two screws, one on each end. There's one here and one over here. This is different than most of the movements we've worked on. Most of them use 3 screws to hold their barrel bridge, but this one uses only 2. There's several components that need to be installed on the top of the barrel bridge, like the ratchet wheel that goes over the barrel, and the crown wheel that goes here, and the click spring. I'm going to wait to install those though because we need to install the drivetrain wheels first because the ratchet wheel goes over the top of the 4th wheel. So those have to be installed first. The escape wheel is going to be the first one we put in, and it goes into that jewel way down there next to that gear. And then the 3rd wheel goes into this hole here, and there's a jewel at the very bottom of that hole that the lower pivot of the 3rd wheel goes through. And then the 4th wheel is actually going to go through this jewel here and has a long spindle that goes down through the center of the center wheel, which is the center wheel spindle is hollow, and it'll stick out all the way through the other side of the movement because the second hand rides on the bottom of the 4th wheel's spindle, so it has to go all the way through the center wheel and then through the movement base plate and then stick out through the cannon pinion on the other side. And actually I should probably just install the cannon pinion before we do anything else, so let's go ahead and do that, and then we'll install the drivetrain wheels and the escape wheel after that. The cannon pinion goes over the center wheel's lower spindle, which is right here sticking out through the base plate. So the cannon pinion is going to go over the top of that. And before we put that on, I'm going to put a little tiny drop of the Mobius HP 1300 oil around the bottom of the center wheel post to help lubricate the cannon pinion when it turns. And we're just going to put a little tiny drop of it on here, not a whole lot. There we go. Here's the cannon pinion, and it has a long tube with a little gear at the bottom. The tube is what actually carries the minute hand. And so we're going to put this right over the center wheel tube. Just like that. And then it snaps down into place, so we need to push it down until it snaps or locks into place. And the way we're going to do that is we're just going to use our tweezers for it. If you put the tweezers around the tube and push them down against the gear at the bottom, and then gently and slowly, you don't want to jam it down there fast or hard, just gently and slowly push it until it snaps into place. There, you just heard the snap, so now it's locked into place. Before I install the drivetrain wheels, I think I'd like to put together the keyless works. And the first thing we need to do with that is install the minute wheel and then the minute wheel bridge. Here's the minute wheel, and it goes on this little post right here next to the cannon pinion. Here we go. Now the next thing we need to put on is the bridge that holds the minute wheel in place, and it's held on by 2 screws. And you can see the holes. There's one hole here and one over here for the 2 holes that hold the minute wheel bridge on. I've got the minute wheel bridge installed and both with screws in place. Next I need to install the winding pinion and the clutch, and then I'll put the stem back in to hold those in place while we install the yoke and the yoke spring. Here's the winding pinion. One side of it has this pattern of these like sort of triangular bumps cut into it, and the other side is flat. The flat side goes toward the outside of the movement, and the side with the bumps goes toward the inside of the movement. And we're just going to drop it in to this slot right here. Just like that. Now the next thing we're going to put in is the clutch. Here's the clutch. One side of the clutch has like a sharp sort of gear teeth cut into it, and the other side of the clutch has that same pattern that's found on the winding pinion. This is called the clutch face, and this is going to face toward the winding pinion when we put it in. And the side with the gear teeth will face then toward the inside of the movement. And we'll just drop it in here right in front of the winding pinion. There we go. Now it's in place. Now we can put the stem in to hold those in their proper place so that they don't fall back out. The stem has to go through both the winding pinion and the clutch. I had to take this off camera and look at it through the loop to make sure I had it in correctly, because I felt like that this should have pushed in a little further, and it turns out I do have it in all the way. It's right, so we're good where it's at now. The next thing I'm going to do before I put in the yoke and the yoke spring is I'm going to put in the detent lever, because that'll hold the stem in place. This is the detent lever, and it's a two-part assembly. It has the lever itself, and then it has that spring that has a hole on it that the screw goes in that holds this in place. And the end of the spring that goes onto the detent lever is just a fork that shoves onto that post that sticks up, and the post is the button that you push to release the stem. So this will fall off easily. If I would turn this on its side, it would fall right off. So that's something you have to be careful of, that it doesn't come back off. Sometimes it's easier just to put the detent lever in place and then shove the spring underneath it and try to latch it in then after you put the detent lever in place on the movement base plate. So this goes in upside down with the post that you see here pointing downward into the movement. And there's a hole that it goes into. And that's that big hole there right next to where the stem goes in. That's where the post goes in. That's the detent lever's post, which is also the button that you push to release the stem. I got it in. I had a heck of a time getting everything lined up. This is kind of a pain to set up, but once I got it in, it works. You can see when I pull the stem out that the detent lever moves back and forth and holds the stem in place. There's a knob that sticks down from the bottom of the detent lever that fits into a groove in the stem, so that when you pull the stem in and out, it turns the detent lever. And that serves two purposes. One, it holds the stem into the movement, keeps it from falling out. The other is that when you pull the stem in and out and activate the detent lever like that, the detent lever is going to push against the yoke, which will move the clutch back and forth to engage either winding mode or time setting mode. And I'll demonstrate exactly how all that works once we have the full keyless works put back together. But it is working the way it should now. So the next thing we need to do is put in the yoke. And the yoke goes in over this post right here, and then goes across here, with the end of it going into that groove on the clutch. And so we can just set it in place. Okay, now take note of the orientation of it. One side of the yoke is straight, and the other side has these curves in it. The curved side goes toward the outside of the movement, and the flat side goes toward the inside of the movement. And the tip of the yoke goes into that little groove there in the side of the clutch. So it's important that all be oriented correctly, and that groove that the tip of it go into that groove in the clutch, so that when the yoke moves, it'll push the clutch forward and backward. The next thing we need to put in is the yoke spring, and the yoke spring goes behind the clutch. It starts up here, curves around through this little circle, and then goes along the back of the clutch to provide tension on it. It's kind of shaped like a cane, and putting that in is kind of tricky. You have to kind of position it and then hold your fingers over the end of it, over the side of it, while you work it in with a screwdriver into its proper final position, because otherwise it'll go flying across the room when you try to do that. You have to hold it in place with your finger, and I can't demonstrate that on the camera without losing the spring or not being able to see what I'm doing, so I'll just show you how it looks once it's finally put together. Alright, I've got it in, and this was a real pain to get in, but you can see how it goes along the back of the clutch through the little circle here, and then ends right down there where it pushes against that little ledge right there. So the next thing we need to do is put in the intermediate wheel, and then we can put in, oh, you know what? I messed something up. The intermediate wheel has to go underneath the minute wheel bridge, underneath there. So I need to take the minute wheel bridge back off and put the intermediate wheel on. And then after that, we can put on the set bridge. I loosened one of the minute wheel bridge screws. This one here, I loosened it, and then I completely removed this one so I could swing the minute wheel bridge out of the way. This post right here is what the intermediate wheel goes on, so we need to put that on, then we can put the minute wheel bridge back in place. I have the intermediate wheel in place, and you can see now how when the clutch pushes against the intermediate wheel, the teeth on the clutch, when the clutch turns from the stem turning, will then turn the intermediate wheel, which will then turn the minute wheel. And so that's how the time setting mode works when you pull the stem out so that you can set the time on the watch. So now that I've got that in place, we can go ahead and put the minute wheel bridge back in place. We can swing this back over to where it belongs and put the screw back in. And you can see how this is going to cover up the intermediate wheel there and keep it from falling out. Here's the set bridge. Now this goes over the keyless works and holds everything in place so that the yoke and the yoke spring don't come out. And you can see it's got 2 holes in it. One of them is for the screw that holds it in place, and the other is an alignment hole. The alignment hole goes over the peg on the base plate that also holds the yoke in place. Now the long skinny extension you see coming out from it is called the detent spring, and that's going to engage with the detent lever. I'll show you how that works once we get it installed. I have the set bridge installed, and you can see how it sits in place. There's the alignment hole with the peg for the yoke sticking up through it. The screw's in place here in the other hole. Now it's kind of tilted downward so that it holds the yoke spring in place. This is kind of unusual because I've never seen another movement design where the set bridge was mounted at an angle tilting downward into the base plate like that. Usually there's something underneath it that holds it level. This one is the same as the other HMT watch I have. It was the exact same way, so that has to be the way it was designed. Now, something else you'll notice is the detent spring here. It's not engaged with the detent lever right now. It's easier to put this in place without trying to engage this onto the detent lever, because if you put the detent levers, there's a little post that engages with this on the detent lever, and it's underneath it right now. If you try to engage this before you put the screw in, it's almost impossible to get the screw in to get it aligned correctly. So I put the set bridge on first, and then I take a screwdriver, just a real small one, and kind of push the spring back until it engages with the post that it's supposed to engage with. Okay, there we go. Now it's engaged. I had to push the detent lever itself back slightly, and then it popped into place. So what this does is that little post sticking up from the detent lever, when you pull the stem out, the detent lever moves forward, and then that post snaps out of here and into the second detent on the spring. And that's what gives you when you pull the stem in and out, it locks into place in the in position or the out position, and this detent spring and that post on the detent lever is what gives you that snapping into place and locking into place. I can show you how this works now. Right now the stem is pushed in, so it's in the winding position, and you can see the clutch is pushed up against the winding pinion, so when I turn the stem, it turns the winding pinion. That winding pinion will engage with the crown wheel on the top of the movement once we have that installed in order to wind the watch. Now if we pull the stem out, see how the clutch pops forward then and engages with the intermediate wheel, which is hidden underneath the minute wheel bridge. And you can see how the detent lever went forward, and the detent spring on the set bridge then engaged the pin to lock it into the pulled out position. And see, when we turn it now, it turns the minute wheel and the cannon pinion so that we can set the time. Now there's one other piece that we're going to have to put onto the watch here, and that's the hour wheel. And the hour wheel goes on top of the cannon pinion, and the gears on it engage with the minute wheel. So I'm not going to put that on right now because it's only held on by the dial. And since I'm not going to put the dial on right now, if I put the hour wheel on, when I flip the base plate over to work on the other side of the movement, the hour wheel is just going to fall off. So we'll put that on last right before we put the dial on. But that's also part of this. I'll go ahead and put it on and show it to you now how it works. It just slides over the cannon pinion, and then you can see how it turns then too. And when the hands are put on this, the hour hand will go on the hour wheel's post. Then you can see the top of the cannon pinion sticks up out of the top of the hour wheel. That's where the minute hand is going to go. And then there'll be a third post, a little thin post sticking up through the middle of the cannon pinion that will carry the second hand. And that's actually the bottom of the fourth wheel, the bottom of the fourth wheel spindle. And since the fourth wheel is not installed, you can't see it yet, but that's going to be on there when we have everything assembled. But you can see how turning the stem turns the hour wheel, and it's also turning the cannon pinion too, even though it may not be visible right now when it's in time setting mode. And then we can push this back in, put it back into winding mode. So that's how the keyless works functions. That's how you change from winding mode to time setting mode, and how the time setting gears work to move the hands when you're setting the time. Everything's assembled on this side of the movement except for the lower jewels for the balance wheel, and we'll put those on later when we're ready to put the balance wheel on. We're going to work on the Watchmaker side of the movement now, so I'm going to put this back into a movement holder so that we can work on it. I'm going to assemble the drivetrain gears now. We're going to do the escape wheel, the third wheel, and then the fourth wheel. And the reason I didn't put this into a movement holder when I was working on dial side of the movement is this dial, or this movement, the shape of this movement, for some reason, when I try to put it into a movement holder with the dial side up, it's impossible to tighten my movement holders around it. When you try to tighten them on, it just pops right out. It just will not stay in the movement holder I got. And these are good Bergeon movement holders, so I'm not using cheap off-brand ones. This movement just doesn't like them. So when I'm working on the dial side of the movement, I just have it sitting on Watchmaker's paper on my desktop. But when I work on the Watchmaker side of the movement, I must use a movement holder, because you can't, with these posts sticking down here, you can't set it on the table by itself and work on it without damaging those posts. Where this stuff here that's on the Watchmaker side of the movement, none of that will be damaged by sitting against the tabletop. But this post sticking down will definitely be damaged if we put pressure on it. So it needs to be in a movement holder to work on the Watchmaker side of the movement. Before we can put the drivetrain wheels in, we need to oil the escape wheel. And the escape wheel is unique because it's the only one of the wheels in the watch where you put oil on the teeth. You never put oil on the teeth of any other gear in the watch. Usually oil is only put on the jewels that the wheel's pivots fit into. So you never oil the teeth themselves. If you did, the watch would be gummed up pretty bad and would lose a lot of amplitude. An exception to that, though, is the escape wheel. The tips of the escape wheel teeth have to have a tiny amount of oil on them so that they'll, when the pallet fork glides against them, it'll move smoothly. And I've always had trouble oiling these things. Trying to hold the escape wheel on a pair of tweezers while using a tiny oiler to put drops of oil on the teeth has always been difficult. And I've always had trouble holding it steady enough to do that. And I'd end up getting oil on top or bottoms of the teeth instead of on the ends. And that can cause problems too, because it can make the wheel out of balance if it's got a glob of oil on top of one of the teeth. And so what I decided to do here is I decided to try something different. You can see here I've got the escape wheel sitting on a Watchmaker's anvil with the pivot stuck into one of the little holes. And that way the wheel itself sits flat on the surface of the anvil. And so what I've done is I've just taken the oiler, and I can come in and touch the tips of the wheel real easily without having to worry about holding the wheel steady. And what I've done is I've only oiled every fourth tooth. You don't want to oil every single tooth because the amount that you want on the teeth is very small, and it's not possible to accurately put on such a tiny amount on every tooth. So what we do is we put a little drop of oil on every fourth tooth, and then once we get the watch running, the jewels on the pallet fork will pick up oil off the teeth that have been oiled and distribute it to the other teeth. And after it runs through a few cycles, after the wheel has turned a full turn several times, the oil should be distributed evenly among all the teeth, and all of them should have the correct amount then. Plus it also will be oiling the pallet jewels at the same time. And so I've got that done, and this worked out really easy. This was so much easier than trying to hold it in my hand. So now I just need to pick up the escape wheel and put it into the movement base plate. Now the oil that we use for this, for oiling the teeth, and we're only oiling the very tips of the teeth. You don't want any oil on the sides or the tops or the bottoms of the teeth, just the tip that faces outward. The oil that I'm using is Mobius 9415, which is a special oil made just for lubricating the escape wheel and pallet fork. And it looks like a gel. It doesn't really look like an oil. It's like a yellow, kind of a thick gel. But when the watch starts running, it liquefies once it starts moving. The escape wheel is going to go into this jewel that's recessed way back here under the center wheel bridge next to the center wheel. All right, the escape wheel is in place. Now we're going to put the third wheel in next, and it's going to go into this hole right here. And it has a long spindle that goes down into the jewel at the bottom of that hole. After we put it in, we need to put a little drop of Mobius 9010 on this jewel here, because that's where the fourth wheel is going to go into. And then we can drop the fourth wheel in. The third wheel's in now. I had a little bit of a hard time getting its lower post into the jewel way down there, but I finally got it done. Now the fourth wheel goes on top of that into the jewel that we oiled. The center wheel's post is hollow, and the fourth wheel's spindle goes through the center of that, because the bottom of the fourth wheel spindle sticks out through the other side of the base plate to hold the center, or to hold the second hand. And so we're going to stick it through the middle of that jewel that also holds the top of the center wheel. And all these have to go in the specified order that I've done. Escape wheel first, then third wheel, then fourth wheel, because of the way that they stack on top of each other, or else they won't interact correctly. There we go, the fourth wheel is installed. Now I can install the train bridge. It goes over the top of that and holds the fourth wheel, the third wheel, and the escape wheel with its upper jewels. I've got the train bridge on. It's held on by two screws, one here and one here. It was fairly easy to get on, except that I had a little bit of a hard time getting the escape wheel to line up correctly, because it kept wanting to set at a tilt because of the way it has a longer lower a longer lower staff than most escape wheels do because it has to sit over the top of the center wheel in this design. So it kept wanting to tilt over and touch the center wheel, and I had a little bit of a hard time getting it in there correctly where it would stay in place so I could get the train bridge down on top of it. But I finally got it in. Everything's working. If we kind of nudge the barrel here a little bit to make it move, you can see that it sends them all into motion like it should. Let's change the focus here and see if we can see the escape wheel. It's kind of barely visible, but let's see if we can see it move. There we go. I had to get the tweezers down to engage the barrel teeth. So you can see everything's moving. So we need to put on the ratchet wheel and the crown wheel and the click and click spring. So the first thing we need to do is put the click spring in, and it goes into this recess right here that's cut down into the top of the barrel bridge. It's shaped like a cane, and the short end of it goes here into this hole, and then it curves around here and goes out into this opening here where the click goes. So I'm going to go ahead and put that in, and putting that in is kind of tricky. You have to hold it down with your finger while you use a screwdriver to kind of maneuver it into place into that recess, or else it'll go flying away. The click spring is in. You can see how it curves around inside that recess and how the long end of it sticks out into the spot where the click is going to go. Now I'm going to put on the click next, and then put on the ratchet wheel. I've got the click installed, and notice how I've got it oriented where it's kind of pointing that direction. The reason is because underneath the first tie-in on this, there's a little nub that sticks down, and that has to go on that side of the click spring, so that when the click turns counterclockwise as you're winding the watch, the click will engage with the click spring that way. So we're going to go ahead and put on the ratchet wheel next. Here's the ratchet wheel, and you can see that it has a square hole in the center. We need to line that square hole up with the square top of the barrel arbor so that it will turn the barrel arbor when it turns. I've got the ratchet wheel on, and you can see how the square barrel arbor lines up with the square hole in the ratchet wheel so that they lock together. Now I need to put the screw on. I need to remind you that the screw for this one is a left-handed screw, so we need to turn it the opposite direction you would normally turn a screw. A normal screw you turn clockwise to tighten. This left-handed screw has to be tightened by turning it counterclockwise. I have the ratchet wheel screw on. Now we need to put on the crown wheel. And the first thing we need to do with the crown wheel is we need to put on the crown wheel washer, which goes over the crown wheel post here. There we go. Now we put the crown wheel on. We install the crown wheel by simply laying it over the crown wheel washer on the post. I want to make sure it's pushed down all the way and that it's teeth mesh with the teeth on the ratchet wheel. It looks like there's some lantern dust or something on there too. Now maybe that's just a scratch on it. We'll see after I'll look at it through a magnifier just to be sure after I put the screw on. Okay, the screw for this is a left-handed screw, just like the one for the ratchet wheel was. And it's actually pretty standard for crown wheels to have a left-handed screw. Most of all watches are designed that way. What's unusual is that this one has a left-handed screw for the ratchet wheel. Those usually do not have a left-handed screw. So this one we're going to tighten by turning it counterclockwise, just like we did for the one for the ratchet wheel. Ratchet wheel screws in. The next thing we need to do is lubricate the jewels for the train wheels. Each of these 3 jewels, I put a small drop of Mobius 9010 light oil on, and then I turned the movement over and added the same oil to the corresponding jewels in the bottom, which on this watch would be this one and this one. This one is for the escape wheel, and this is for the third wheel. The fourth wheel doesn't have a lower jewel. The fourth wheel lower spindle sticks out through the bottom of the cannon pinion there, because that's what's going to carry the second hand when we put the dial and hands together. Now that I've got the jewels lubricated, I want to test the drivetrain and make sure that everything is working smoothly. So I'm going to wind the watch some, and you can see the gears are all in motion. Notice how the escape wheel slightly backlashes a little as it ends. That's the way it should be, so everything is working the way it's supposed to now. Perfect. The other HMT watch I assembled did not do that because I think the escape wheel on that one had a slightly bent or damaged pivot from me dropping it. This one's working great, so we should be able to get hopefully good amplitude out of this watch once we put the balance wheel in. And right now, the first thing we need to do before we can do that is we need to put in the pallet fork and the pallet bridge, and then we can put in the lower jewels for the balance wheel and put in the balance wheel and see if it works right. The pallet fork is going to go into this jewel right here next to the center wheel. And when we put it in, we need to make sure that the long part of the fork goes between the banking pins. And this one is a little bit tricky to get in because for the same reason that the escape wheel was. The escape wheel and the pallet fork are both elevated above the base plate higher in this movement than in many other movements because this design puts the center wheel at the bottom of the movement rather than putting it at the top of the movement like most do. And so they have to be elevated above the center wheel, and that makes it tricky to get it in because it wants to tilt on its lower pivot instead of standing up straight. I've got the pallet fork installed and the pallet bridge installed. The pallet bridge is held in place by a single screw, and there's also 2 alignment pins that stick up from the bottom of the base plate that go into holes in the pallet bridge for alignment purposes. If you align the 2 holes with the pins and you have the screw hole aligned, the jewel should also align, hopefully, if everything's set up right, with the pivot on the top of the pallet. Now, we're not going to put any lubricant on the jewels for the pivots for the pallet. So this jewel up here and the jewel on the bottom of the base plate that corresponds to it will remain unlubricated. If you put lubricant on the pallet fork, it tends to slow it down too much because the pallet moves very rapidly, but just in little short strokes. The oil doesn't actually make it move smoother. It actually gums things up and slows it down and can rob you of a lot of amplitude. So we're going to leave that unlubricated. We're ready now to put in the balance wheel. And before we can do that, though, we need to put in the balance wheel jewel system. And there's a lower jewel system that goes in the base plate. There's an upper jewel set that goes in the balance cock. And they consist of 2 jewels. There's a small jewel that is set into a spiral-shaped spring that sits into the base plate. And the pivot for the balance goes through the center of that, just like how these other jewels work. And then on top of that is a cap jewel that the tip of the pivot pushes up against, and that goes on top of the jewel with the spiral spring. And we're going to assemble one of those sets on the base plate and on the balance cock. We're ready to assemble the lower balance jewels, and they go into this hole right here on the base plate. Now, the balance jewels consist of 2 parts. There's a lower jewel, which is a small jewel inside a spiral-shaped spring, and that goes in first. And that jewel is going to go in. If you look at the jewel through a magnifier, you'll see that one side of the jewel has an oil cup in it, and the other side of the jewel does not. The oil cup side goes facing down toward the base plate, and that's the first thing we're going to put in. Here's our spring, and it just drops into the hole there. And I need to double check it and make sure that it's laying flat. And I'll have to do that looking at it through my eye loop. Okay, it wasn't laying flat, so I had to correct that. I couldn't see it on the camera's little screen very well. The next thing we need to do is add the cap jewel. And the cap jewel has 2 sides. One side is deeply recessed into the metal housing, and the other side is not. The deeply recessed side is the side we're going to oil, and that's the side that goes down when we put it into the base plate. I'm holding the jewel with a jewel picker, and I put a little drop of Mobius 9010 oil on this, on the side that's on the recessed side of the jewel. And I'm going to place that facing downward into the movement base plate then. If you look at the metal housing that holds the cap jewel, it has 2 little metal tines sticking out from it. One's here, and the other I've pushed underneath the little ledge around. There's like a little lip around the opening. I pushed one of them under the lip, and the other one is sitting into this opening in the lip. And that opening is for us to push the other tine down and then rotate it so that both tines are under the surrounding lip, and that will hold it in place. Let's see if I can show how to do this. So what I'm going to try to do is use the tweezers to push that down, and I'm going to use a piece of sharpened pegwood to push down on the jewel too so that it won't pop out when I'm trying to rotate it. There we go. See how it's rotating under the lip that surrounds the holder for the jewel? And now I've got it locked in place. Now I want to turn it a little bit further just to make sure that it doesn't vibrate free in the future. There we go. That's all there is to it. And I'm going to go ahead and do the one for the balance cock too. And then once that's in, then we can put the balance cock in and install the balance wheel and see if it comes to life. All right, here it is. I got it running. I ended up putting a different balance wheel on it because the one that came with this watch, when I put it back together, the hairspring was tilted real strongly to one side. And I had another balance wheel that was a good one for the same movement in my parts collection. So I put it on. It's working beautifully. So we need to let it sit for a while before we can do the final regulation on it. It needs to sit for a minimum of 24 hours. And usually I let them sit a couple days because I found that even after 24 hours, if I regulate the watch, in a few days it's going to drift some anyway, and it's going to need to be regulated again. So I may wait a couple of days before I do the final regulation, but it is running now. It's got good amplitude. You can see the balance wheel is really swinging real far. Huge improvement over how it was before we started working on it. So this watch is going to be one that's going to be a nice one, I think. Once I get it regulated and then put the dial and hands back on it, get it back in the case, it's going to be a nice watch to wear. Here's our initial Timegrapher readings. Plus 17 seconds today is great. We can regulate that out easily. 240 degrees of amplitude is excellent for a Japanese-derived movement. Remember that they run at lower amplitudes than Swiss movements. This is a citizen movement design. Beat error is 0.9 milliseconds. That's barely acceptable because it needs to be less than 1. Now it is 1 millisecond. So I may try to regulate that out when I do the final regulation. So yeah, this looks excellent. I'm going to wait a couple days before I do the final regulation on it, but we made a huge improvement over what we had before. Okay, it's been a couple days since I finished assembling the watch, and I've got the movement on the Timegrapher again because I've been messing around with trying to correct the beat error. If you recall from seeing the Timegrapher results earlier when I had first put it back together, we had beat error of about 1.1 milliseconds, and I wanted to correct that out. And this is the first time I've ever successfully corrected beat error by adjusting the hairspring collet. And so check out these numbers. Here's the Timegrapher. The rate's negative 4 seconds a day. It looks like it's fluctuating a little bit. It was -7. But look at the amplitude, 280 degrees of amplitude. And check out that beat error. 0 milliseconds of beat error. Absolutely perfect, flawless. And it took a few tries. I took the balance off the movement and adjusted the hairspring collet 6 or 7 times to get this right. Because the first time I did it, it went from 1.1 milliseconds up to like 1.5. Okay, well, that's even worse. So I tried adjusting it the other direction, and then I got it even worse. I got it up to like 3 milliseconds. And then I adjusted it again and got it down to 2, and then adjusted it again and got it down to 1.2, and then adjusted it again and I got it to 0. I think all in all I did it 6 or 7 times. I can't remember how many adjustments exactly, but I know that I did it several times, and it's a real pain because every time you've got to take the balance off the movement, hang it on a balance tack, make the adjustment to the hairspring collet, put it back on the movement, and then put it on the Timegrapher and see what the results are. And then if it's not right, disassemble again, make the adjustment, reassemble back on the Timegrapher. I've been working on this for quite a while now, but it's paid off. I got 0 milliseconds of beat error. The amplitude is a lot better now too, 279 degrees of amplitude right now. That's very, very good. I suspect the amplitude has gone up since the earlier testing because of the watch sitting for a couple days and running and getting all the lubricants worked in. So everything's running smoother now, which would increase your amplitude. Fixing the beat error also would make the amplitude better. Our rate is -6 seconds a day right now, it looks like. We can improve that. So next thing I'm going to do right now is work on regulating it and getting that closer to perfect, and then we can put the dial and hands on. I'm ready to do the final regulation of it, and as we saw in the Timegrapher just a second ago, we're running at about -6, -7 seconds a day, and the beat error is absolutely perfect, so I just need to correct out that rate, and that should be fairly easy to do. And I've got the camera zoomed in on the balance wheel and the regulating mechanism. If you look at it here, this here is what carries the hairspring stud, and on this movement it's not adjustable. It's in a fixed position. That's why I had to take the balance off and adjust the hairspring collet in order to correct the beat error, because you normally on a more modern watch you would just move this. It swivels back and forth to adjust the beat error, but on one like this it's got a fixed hairspring stud. You can't do that. Now the other lever here next to that is the regulating lever, and that's the one that you can swivel back and forth to adjust the watch's rate. And you turn it clockwise on this movement to speed the rate up. In other words, you move it away from the hairspring stud to speed the movement up. And if you wanted to slow the movement, you would move it counterclockwise or move it toward the hairspring stud to slow the movement down. Now we need to speed this movement up slightly. Now the thing is that even teeny amounts of movement on this make a big difference in the rate. So you want to move it just a tiny, almost microscopic amount. Like if you can see it move, it's probably too much. So I just gently nudge it just a teeny amount and then put it back on the Timegrapher, especially when you're trying to correct out an amount that's so small. If it was off by like 30 seconds or something, then a little more movement could be tolerated, but we're trying to correct out an error of 6 or 7 seconds. So we barely want to move this just a little bit away from the hairspring stud. What I'm going to do now is I'm going to push the regulator just a little bit away from the hairspring stud in order to speed it up slightly, because I want to get it to where it's either 0 or just slightly fast. Right now it's about negative 6 or 7 seconds a day, and so I'd rather get it. If it can't be perfect, I'd rather have it a few seconds a day fast than slow. The tool I'm going to use for this is actually one of the hand levers I use for removing hands from watches. This is a small Horatech one, and I think it has it's 1.5 millimeter or 1 millimeter width, and it has a forked end. It's a smaller size Horatech one, and this is perfect for adjusting the regulators on watches because it's small enough that you can reach in there and touch that lever, and it has a little fork on the end that lets you kind of capture the lever so that you can push against it without it slipping off. Because if you use something like a screwdriver, it can slip off and hit the hairspring and mess things up, where this is a lot more reliable. So what I'm going to do is I'm just going to very carefully reach in here with this. And this looks a little more awkward than it really is because I normally do this looking through an eye loop instead of trying to look at the camera's screen. But I'm gonna reach in here and kind of touch the top so I know where I'm at, and then slip the forked end over the side of it. And like I said, this goes a lot easier if you're looking at it through an eye loop. I think I may have to just do that anyway. What I did was I put the tool against the arm that carries the regulator pins, and just gave it the teeniest little nudge where I really couldn't even see it move, just a teeny little nudge. And I'm going to put it back on the Timegrapher and see what kind of results I've got. Hopefully I didn't push it too far. Look at that, 0 milliseconds of beat error, 0 seconds per day rate, and an amplitude of 287. That is awesome. I think we're going to be happy with that. After I got the movement regulated to 0 seconds per day in the dial-up position, that's the position I had it on the Timegrapher for what you just saw, I decided to go ahead and check it in the crown right and crown down positions to see how it performed in those areas. And I didn't get a lot of positional variance. In the crown down position, it was running at about negative 5 seconds per day, and in the crown right position, it was running at about 8 seconds per day fast. I think that all those together, when it's being worn on the wrist, will equal out to something pretty close to a perfect result. So I'm going to leave it as it is now, and once I get it put back together, wear it for a week or so and see how it works out. So right now we're ready to go ahead and do the final assembly of it. We need to put the dial and hands on, and then we need to case it up, and I've got a new strap to put on it too, and we'll be all finished then. So let's go ahead and do the dial next. Before we can install the dial, there's a couple things that need to be installed onto the movement. First off, we need to put on the hour wheel, and the hour wheel just slips over the top of the cannon pinion. Just like that. Make sure it meshes with the minute wheel. And then on top of that goes the dial washer. Just like that. And then now we can put the dial on. Here's our dial. Now I'm going to, that looks like it's a little dust I need to blow off. Now the next thing we need to do is put the dial screws in. There's 2 dial screws. One goes there and one goes on the other side of the movement. And that'll lock the dial in place, and then we can put the hands on. I've tightened the dial screws. I've gone ahead and set the hands. I want to give you some information about proper setting of the hands. The hands stack on top of each other with the hour hand at the bottom, the minute hand above that, and then the second hand is on top. And you put on the hour hand first, and the hour hand, when you put it on, it has to point directly at one of the minute markers. It doesn't matter which one you choose. I've chosen the number 1 here, but you can use any of them. And then the minute hand must be put on pointing directly at the number 12. And the reason for having them aligned like that is that if you put the minute hand pointing anywhere else, the hour hour and minute hand won't be coordinated with each other, because when the watch works normally, when the minute hand comes up to the 12, the hour hand needs to be pointing directly at one of the hour numbers. And if you didn't align them the way I've just told you, then they won't do that when the watch is running. You could have the minute hand come up to the 12 and the hour hand pointing between 2 numbers, which is inappropriate. So they need to be set like that. Now the second hand isn't important. It doesn't matter where the second hand is pointing when you put it on, but the hour hand must be pointing directly at one of the number markers and the minute hand must be pointing directly at the 12 when you set them. So the next thing I need to do now is I need to get the case out and clean the inside of the crystal, and then we can set the movement into the case. I've got the case ready. What I need to do next is put the movement ring in. There's a retaining ring that goes around the movement, and if you look at the retaining ring here, there we go. I'm having a heck of a time getting the camera to focus on this thing. So that's how it gets oriented. This is the top side of it, and that cutout goes over the stem. So we need to turn the movement over, and I'm going to hold it in my hands carefully so that I don't damage it. And I think what I'm going to do first is set the movement into the case without the movement holder, and then put the stem in and then put the holder over it. I believe that's how it should be done. And I'm going to take the case and set it directly over the top of it with the stem tube by the 3 o'clock position. And then I'm just going to flip this over in my hand, just like that. And then I'm going to put the stem back in. You need to make sure the stem lines up with the hole in the movement when it goes in. And you have to kind of rotate it to get it to the point where the square part of the stem will go into the square part of the clutch inside there. Oh, there we go. Sometimes it can be a pain to get it aligned, but there it goes. It's still not wanting to go in all the way though. I think that's because I had it out in the time setting position instead of in the winding position when I pulled it out. I'm going to go and put the retaining ring in, and then that way it'll get the movement centered where it needs to be, and hopefully it'll be easier for me to push that the rest of the way in. You know, that's not wanting to go down in there. I wonder if that had to go in there. I had to pull that off before I could get the dial off, so I know I didn't have to put it back on before I put the dial on. It doesn't look right though. You know what? I bet I needed to put that on with this part upside down and the stem on top of it. Crap. Let me look at my video that I made and make sure that I'm putting this in the right way. I do have it upside down, so I'm going to have to pull the stem back out and then put the movement holder in without the stem in place, and then put the stem back in after that. I took the movement back out of the case so that I could double check the alignment of this, make sure everything was set up correctly, and it is. I've got it pushed down all the way now, all the way around. You can tell because there's those little feet that touch the dial, and those are all over in place where they should be. So now that I've got this in, now I can put it back into the case, and we'll do it the same way we did it the first time. I'm going to blow the dust off again. Set it on the casing cushion. Set the case over it with the stem tube by the 3 o'clock. Flip it over, and then we'll see if I can get the stem to insert this time. And it looks like it's, yeah, there we go. It was a little bit off. I may have to push the stem retaining screw down to get it to let the stem go the rest of the way in. So we'll try that. I really screwed this up. When I was trying to push that stem in, the stem broke in half. Fortunately, I do have another stem and crown for this movement, and it's the same size stem as this one, so it'll fit, but it has a silver crown on it. I'm going to have to try to unscrew the crown and put the gold crown onto it, but this one I put in, it actually snapped right in. So I don't know what the issue was with the original stem. The original stem did look like it was slightly bent, and it was like that when I pulled it out of the movement the first time, so that may have been why I couldn't get it to go back in very easily. So I'm going to have to get this silver crown taken off this new one and put the gold crown on it, and then we can finish putting this all together. Alright, well, getting the old crown off was fairly easy. I put the broken stem into this pen vise and just unscrewed the crown with my fingers. So let's do the same thing with the new stem. Here's our new stem and crown. I'm going to stick it into the pen vise. Tighten it down. Get it nice and tight so I can turn this without it turning in the pen vise. And I can just unscrew this just like that with my fingers. Now let's see if we can just tighten the new one on, or tighten the gold one onto it. That was easy. Tighten it on nice and tight so it don't come off. And now we can take it out of the pen vise and hopefully get this into the movement. Oh, it's not locking in place though. Oh, maybe it's not long enough after all. Let's double check this. I couldn't get it to lock in, so I took the crown back off that stem and compared it to the old stem, the old broken one. And I put the broken one where I sat the pieces back together so that you can see how long it is, and to compare it to the new one. This is the shorter one at the top here is the new stem that I've got, and you can see it's just slightly shorter by about 2 millimeters than the one that I broke. I have another HMT stem as well, but it's also even shorter than the one that I just tried. So I'm going to have to try to find another longer stem before I can complete this. So for right now, we're done with this until I can get another stem for it, since I managed to break the stem that came with it. So hopefully I can fix this one. There's I'll see if I can find maybe a Citizen stem that'll fit it, or maybe if I can find an HMT parts wash, because I've got a pretty good collection of HMT parts already, but I just don't have any other stems other than these two that are both too short. So for right now, I'm just going to set this on the side, and if I do find another stem for it, I'll make another video showing the process of putting the new stem together and completing everything. For right now, I'm just going to go ahead and put the case back on this one, since the movement itself is done and is running beautifully and everything. I'll go ahead and put the case back on it, and that way it'll be sealed up against dust and moisture and whatever, and I'll put this aside until I can find another stem for it, because I do want to complete this one. I like this watch and I want to be able to wear it. So for right now, though, we'll have to wait.